Hello and welcome to the Bearded Math Man's YouTube channel. Hey, this is part 2 of our introduction to functions, and in this part we're going to be talking about what domain is and how to find domain. We're going to be talking about what range is and how to find it. So let's start off with an example, shall we? Let's say you're given a graph like this and you're being asked to find what is the domain and what is the range, right? Well, let's talk about what a graph is first, so that when we see the definitions for domain and range, we understand what it means. So a graph is a picture of all solutions to some equations, or all sets of ordered pairs, inputs and outputs to some function, right? So like, for example, this point right here, 0, 4. Well, x is the input, and that's 0, and y is the output, and that's 4. So this is one input and output pair, right? You could also say it's f of 0 equals 4. Now, the reason that's important is because domain is the set of all possible inputs. This is one input of 0. So set of all possible inputs. So that's all of the possible x's that would be mapped on a graph of an equation. And range is the set of all possible outputs, right? So on this graph right here, we're going to assume that the pattern continues as the graph goes off of the coordinate plane view that we have. So it's going to continue to go up and to the left over here, and it's going to continue to go up and to the right over here. Because it's going to the left, and it's going to the right, the domain is going to be all real numbers. The domain is going to be any number you could possibly think of that's a real number. That means, not the square root of a negative, right? Now, the range is a little trickier on this example right here. It's true that the range, that the outputs continue to go up, but there's a minimum value. The range doesn't go below here. You see, if we look at this graph, it starts going from left to right, it's going down. It stops and then it goes up, stops and goes down until it gets to here, and it turns around and goes up again. And we're going to assume that it goes up forever, right? So this was our minimum value right here of -8. That's our smallest possible output. So our range is going to be from -8 to infinity. Now, lots of ways to describe domain and range. You could write it as an inequality. You could use set builder notation. You could use interval notation. We're not going to talk about any of those really in this video. We're going to leave those for later. What we're going to really focus on now is what domain and range are and how to find them. We'll use inequality notation when it's most appropriate, but otherwise we're just going to describe it in simple English for now, right? Let's see another example. Let's say we had to find the domain and range for this graph right here. Now, it looks like there is no input to the left of 1. And it looks like there's no output below this y value of 2. So we're going to assume that our domain, based on what the graph looks like, that the domain starts at 1 and goes to the right forever. So the domain is going to be all numbers greater than or equal to 1. And the range has nothing below 2, no output that's less than 2. So our range is going to be all numbers greater than or equal to 2. Now, you might be wondering, if we back up just a little bit, you might be wondering what actually happens at this point right here. Is that point actually included or not? We'll get into that in just a moment. All right, now, some common mistakes that people make is they mix up domain and range with intercepts. So, for example, if a student was going to find the domain and range of this graph on a quiz or on homework or something like that, what they will often say is, oh, domain is all of the x's. And so they look at these two x-intercepts right here and they say the domain's from -2 to 4. And they say the range is from -8 to positive infinity. Well, that's wrong, of course, because, well, domain is the set of all possible, right? All possible inputs. And this graph right here, it's going to the left and it's going to the right. So the domain is going to be all real numbers. And the range is the set of all possible outputs. And there is an output that's smaller than -8. In fact, there's a whole bunch of them. We can go all the way down to -9. So the range is from -9 to positive infinity. You see? So while it's true, we do look at the x and the y axis, the x and y axes, to figure out what the domain and range is, we don't look for just the intercepts, okay? So the domain is all possible inputs, and the range is all possible outputs. Let's see another example, shall we? This one's a little different than all of the others because it stops here on the left and it stops here on the right. So our domain is a set of all possible inputs, and it looks like we're bound on the left at 1, and we're bound at the we're bound at the right at 1, and we're bound at the left at -3. So our domain is going to be from -3 to 1. Now, in just a minute, we're going to talk about these endpoints, what happens at them, and how to tell if these numbers, -3 and 1, would be included or not in the domain. But first, let's talk about the range. Looks like the range goes from here, which looks like about 5.1. Let's see, there's 1, 2, 3, 4, 5. So each one of these is 0.2. It looks like, based on what we have, it's halfway in between here and here. And so we're going to say that's 5.1, and it goes all the way down to, looks like, -1.1. So our range is going to be from -1.1 to 5.1. Now we're guessing these coordinates. We don't have enough information to know exactly what they are, but we're going to guess this from -1.1 to +5.1. Now, if you remember when you did inequalities for one variable or maybe more, a solid dot means the value is included and an open circle means the value is not included. So if I were to have a situation where I had a solid dot on one end here and an open circle on the other end here, well then our domain, if we used interval or inequality notation, our domain would be from -3 is less than or equal to our input values of x is less than 1. Remember, this means that this number is included. The strict inequality means that it is not. However, if they were switched around the other way, right, then we would have the -3 is not included and the 1 is included. Now, neither of these affect the range. All right, now let's talk about finding the domain given an equation or a function, right? Now, the domain, if you remember, it's the set of all possible inputs, right? And this means any number you could put in for x. And if you remember, you can't divide a number by 0. It's undefined. The reason this is because, well, division is kind of like asking a question. The reason that 8 divided by 4 is equal to 2 is because 2 times 4 is 8. And the reason that 0 divided by 4 is 0 is because 0 times 4 is 0. So 4 times 0 is 0. That's true. And 4 times 2 is 8. But 8 divided by 0 doesn't equal anything because there's nothing times 0 that will give us 8. That's undefined. It means it's actually not a number. So if we could figure out a value for x that would make this denominator equal to 0, well, then we found a gap or a missing value in our domain for sure. And so all you got to do is take that denominator and set it equal to 0 and solve it. So what we found out is that if x equals 2, then this is undefined. And that means that you cannot use 2 as an input. So the domain is going to be all real numbers except for 2. Now, for this kind of an equation right now, finding the range is a little beyond the scope of it's a little beyond our level of ability right now. We're going to get into this much in the future. You'll learn how to do it. It's not that complicated, but you have to have some more tools in your toolbox before we can start approaching finding the range for something like this. But in the next video, what we are going to talk about is 4 types of functions, and we're going to be talking about how to find the domain and range for each of those and how to identify them, and that's going to really help you out, okay? So in this video, we wanted to talk about what domain is. Domain's the set of all possible inputs and how to find it from a graph, right? And so all you got to do is look. Range, set of all possible outputs. You should know how to find that from looking at a graph. All right. So here are a handful of practice problems. You can find the domain and range for each of these. If you'd like more information or more practice problems, I'd suggest you go to my website. I'll leave a link in the description below. It's thebeardedmathman.com, but I'll leave a link to a page that specifically applies or is related to the stuff that we covered in this video. If this video has been helpful, hey, do me a favor, give it a thumbs up. Leave me a comment if you have a question, if you like it. Just say hello, whatever you like. Subscribe, share. I hope it's been helpful. Hope you have a wonderful day.